morning, boys and girls, ladies and gents. It's our first lesson. Okay, so I just want to remind you that we've been talking about pressure. We learned about pressure in gases, and then the last couple lessons we learned is how to calculate pressure in solids. Okay, force over area. What we still have to finish is look at pressure in liquids. Okay, we do experience pressure in liquid. If you ever jumped into the pool, okay, do you feel something in your ears? Isn't that? That's the pressure that the liquid pressing onto your ears. There's a couple of things we need to learn about pressure in liquids, and Ella here is going to help me to do that. And our first little demonstration is using this little bit here. Okay, so what we're going to try and find out is how the pressure varies, means changes as the liquid becomes deeper and deeper and deeper. Okay, so let's do that. Okay. Ella, you're going to unplug that top two ones. That's going to
okay.
Yeah, so we're going to go on this side. Okay, hold on to, and we're going to let go on 3. 1, 2, 3. Okay. Right, so we made a little bit of a mess. Okay, I'll put that away now. Right, but we could clearly see that the lower parts, okay, where the holes, the lower bit, water moved faster, further out. That means the pressure becomes stronger the deeper we go. And you know that because if you dive in the pool, okay, the deeper you go, the pressure in the ears becomes stronger and stronger and stronger. Casper, not right now. Okay, now why is that happening? Well, that's quite simple. It's just because the deeper you are, there's more water above you pressing onto you. The weight of the water increases. That makes sense that the pressure will increase as well. So that's the first thing we've learned about pressure. It increases with depth. The second thing I would like to look at is in which direction the pressure pushes on. Now you might think it's all down because gravity pulls the water down, the pressure will be down. But it's not exactly the right because we saw that the water was moving to the side, so the pressure is maybe to the right as well. But what about the lift? Okay, so here is something you could do. Okay, I'm doing it with a bottle because I couldn't find a balloon. But if you have a balloon, that will be better. Okay, and I filled it up with water, and so there's water inside, and therefore also pressure from the water. And what I'm going to do, I'm going to stab, hopefully not myself, but the balloon, the bottle in a few places. If you're using a balloon, then don't use a knife. Just take a needle and spike the balloon in different places. Okay, so let's see what happens. I'm gonna.
Okay, don't break your computer.
So as I'm pressing now, you can see the water. Hopefully you can see it. The water goes in all directions. So what we're learning here is that pressure is, it's a fancy word, it's called isotropic. Isotropic meaning in all direction. Okay, so two things we learn. I'm going to put the whiteboard now for you to make some notes. You can pause me and copy that. But the two things we learn is, first of all, pressure in liquids increases as the depth increases, just like you saw in this demo. Okay, which you can, by the way, do as well if you just put holes in different heights of the bottle. And the second thing, I hope you can see it. If you don't see it, don't worry. I will write it in a neater way. Maybe it's in the PowerPoint if needed. But pressure is also isotropic, meaning it applies in all directions. Okay? Right. That's it for now. I will send another video about one more thing in pressure in hydraulics.